Hello, in this video we'll discuss section 17.3, the sampling distribution of other statistics. In particular, we'll look at the sampling distribution of a mean. So we're going to be considering a quantitative variable, and the example we'll look at now involves a collection of 1,000 pennies. We're going to be taking samples of various sizes from this population of 1,000 pennies, and we'll compute the sample mean. So we'll denote that by y bar, and again, because this is a number associated with a sample, it's a statistic. And the population mean we'll denote by mu. This is a parameter because it describes the population. Let's use an applet to help us do some simulation. So we have the population of 1,000 pennies and their year and ages all contained here. And you can see the display for the distribution of ages. What you notice about the shape is it's skewed to the right, which I think is what we'd expect here. Most of the pennies are relatively new, and we do have a handful of pennies that are quite a bit older. So what we'll do here is we'll start taking some samples. I'm just going to do a sample of size 1 initially. I'll click Draw Samples. And we get the 1 penny selected is 14 years old. So that will be the mean of our sample. Because it's a sample of size 1, the mean age is just the age of the penny itself. So we'll do this a number of times. Let's do it 499 more times for a total of 500 samples. And you can see the most recent sample, the penny was 15 years old. And over here on the right, we have the distribution of the sample means. But again, since each sample is just 1 penny, it's just the distribution of ages. So this distribution has a similar shape to the distribution for the population. It's skewed to the right. What I want to do is record the mean here. I'll jot this down, 12.316, and the standard deviation, 9.527. I'm reading those from this right here. I'm going to record this in a table. The mean was 12.316. Standard deviation was 9.527. And we said the shape was skewed to the right. So we'll return to this in a moment. Now let's do this. Let's increase the sample size to say 5. I'll start by just drawing one sample. And we get this sample of 5 pennies. The mean age among our sample is 14.2. So now let's take many more samples. We'll do a total of 500, so I'll add 499. Here's the most recent sample, and then we get the display for the distribution of the sample means. Now, the mean of the sampling distribution is 12.392. Standard deviation is 4.268. And notice the shape now is much more symmetric than before. So let's record these observations in the table. The mean was 12.392. Standard deviation 4.268. And now the shape, I'll say, is roughly symmetric. Now I should point out the mean of the sampling distribution here, this 12.392, is fairly close to the population mean, 12.264. Let's gradually increase the sample size. Now we'll go from sample size 5 to sample size 25. And we'll do a total of 500 samples. Here's the distribution. And we notice the mean is 12.173. Standard deviation is 1.970. And it's becoming more and more symmetric. So we'll record this in our table. Mean of 12.173. Standard deviation of 1.970. And again, I'll say roughly symmetric. So finally, let's increase the sample size to 50. Draw 500 samples, and here we go. The sampling distribution of the mean looks like this. Its mean is 12.282, 1.354, and it's looking more and more symmetric. So we'll record this in our table. Mean of 12.282, standard deviation of 1.354, and again I'll say roughly symmetric. Let's summarize our findings. Notice the mean of the simulated sample means is close to the population mean of 12.264. And the variability in the sample means decreases as the sample size increases. Notice what's happening to these standard deviations. The other observation to make is that as the sample size increases, the sampling distribution of the mean is approximately normal. So that's our first look at the sampling distribution of the mean. See you next time.